I'm going to seat our panel now, so I'll introduce each of them, and when I do so, please come up and take your seat at the table and put your little name tent up if you would, and then I'll make a few remarks myself before we begin on the panel. So the first person to introduce is Dr. Cynthia Rosenzweig. Would you please come forward? Cynthia is a senior research scientist at the NASA Goddard Institute for Space Studies and an adjunct senior research scientist at the Columbia University Earth Institute Center for Climate Systems Research. That's a lot of words. She is also a professor in the Department of Environmental Science at Barnard College. At NASA's GISS, she heads the Climate Impacts Group, whose mission is to investigate the interactions of climate, both variability and change, on systems and sectors important to human well-being. She is the co-founder and member of the Executive Committee of the Agricultural Model Intercomparison and Improvement Project, a globally integrated transdisciplinary study of climate impacts on the agricultural sector at national and global scales. She's done so much more, and she's here with us to share her thoughts today. Please, welcome Cynthia. Yes, please. Dr. Dennis Toddy is here. Please come forward. Dennis is the director of the USDA Midwest Climate Hub in Ames. He is a native Iowan with his bachelor's and PhD from Iowa State in meteorology and agricultural meteorology. He has spent 2 stints in South Dakota, first completing his master's degree at the South Dakota School of Mines and Technology, and most recently as associate professor and state climatologist for South Dakota at South Dakota State University. He is well known regionally as a speaker and media source on various climate issues and is the former president of the American Association of State Climatologists. Let's welcome Dr. Toddy. Next up, Dr. Mike Castellano. Mike, please come forward. Mike is a soil science professor with Iowa State University. His research focuses on the biogeochemical cycling and transport within the soil as it extends to the atmosphere and the subsoil. His group's ultimate objective is to maximize sustainable productivity of agricultural systems, with particular interest in nitrogen. Nitrogen frequently limits production and is easily lost in our agricultural systems. His work is on minimizing nitrogen limitation in agricultural systems, among the most important global research priorities in the 21st century. To reach these goals, Mike and his team use agronomic, ecological, biogeochemical principles to advance our basic understanding of elemental cycling and improve ecosystem management. Our fourth panelist is Dr. Rick Cruz. Rick, please come forward. Rick Cruz is a professor in the agronomy department at Iowa State University and director of the Iowa Water Center, where he has research, teaching, administration, and extension responsibilities. He served as president for the National Institutes for Water Resources from 2015 to 2016. His program involves field and modeling research in soil erosion, soil management, and soil properties, while he maintains cooperative research projects with the Northeast Institute of Geography and Agroecology at the Chinese Academy of Sciences. These cooperative projects address the soil erosion and soil management effects on soil properties. He also teaches advanced soil management in the Iowa State University Agronomy Graduate Program, meets with diverse audiences to address soil management, soil erosion, and water quality issues, and administers the Iowa Water Center, one of the nation's water resources research institutes. Please welcome Dr. Cruz. And finally, recently on NBC Today's show, Dr. Emily Heaton. Please welcome Emily. Emily is the assistant professor of agronomy with Iowa State University. The Biomass Crop Production and Physiology Lab by Dr. Emily Heaton aims to understand the growth and productivity of dedicated biomass crops in the Midwest and how they can be managed to provide multiple ecosystem services. Emily's lab specifically seeks to elucidate the reciprocal impact of the environment on key physiological processes like photosynthesis, biomass accumulation, water use, and nutrient cycling. Typical activities focus on the plant and field plot scale, with inferences at the watershed and ecosystem scale. Through collaboration, data is used to explain observed phenomena and predict future behavior, with the ultimate goal of providing useful information to policy and the public about the role of biomass crops in the Midwestern USA. So these are our panelists, and we're thrilled to have them. I'll make a few introductory remarks, and then I'll turn over to the panelists, the podium, and we'll go in the order that they appear on the agenda for them to make their presentations, at the end of which I'll start off with a question or two and then call for the audience to ask questions. If one of the individual panelists doesn't mind, you can call out a question midstream, but we do want to stay on track with respect to our agenda. Those are the ground rules, okay? Any questions there? Okay, let me just make a few introductory comments. First of what we're doing here today, I wish we were the first to do it, but we're not. This same work with solutions from the land on climate smart agriculture is happening in other places, Florida, Ohio, North Carolina. Recently, I was on the phone with the Dean of the College of Ag and Life Sciences in Florida, Dr. Jack Payne, and they have been pushing forward on this same kind of conversation with really very, very helpful results. And so we are following a little bit, but we're about to take the lead as Iowa does in agriculture. Iowa Smart must be climate smart agriculture, and I would ask you the question, why not? Why wouldn't we want to be smart about our climate and how we put it to work for us on our landscapes? Let's agree again, as I said earlier, that climate smart and Iowa smart agriculture are not political statements. Your university, Iowa State University, is a university of science and technology, and we are deeply engaged and leading in this kind of thought and the research and extension and teaching that captures the ideas we'll be talking about today. And so as dean of that college, representing the university, we are thrilled to be part of this conversation. We have people working on what you might call the carbon economy, on the plant, soil, and air interactions, on the water and water quality economy, on the energy economy, and finally, and for certain, on the production economy, which includes profitability. None of this happens if the people who manage the landscape can't be profitable and sustainable. Let's figure this out together and commit ourselves to pulling in the same direction. I would observe that no farmer that I have met here in Iowa, or frankly anywhere else around the world, wants to leave their soils and their landscape in poorer condition for the next generation. It is a fundamental desire of anybody who cares about the things that occur in the landscape to want to leave it in better condition for the next generation. And as was mentioned earlier already today, this may be the first generation to actually do so. So we should congratulate ourselves on that, but also look forward to doing even more. There is a new normal out there. Climate seems to be changing for certain. Weather is certainly more variable, there's no question. And so the new normal is, how do we cope with the changes that are upon us? They've already arrived, and we've got to figure out what to do going forward, not just to manage the sustainability of individual farms, but the sustainability of our nation to produce the goods and services that we want from our landscapes, and how we're going to pass this on to the next generations. Even if we weren't in a time when climate change was causing us to stop and think and begin to do things differently, the kinds of techniques and practices we're talking about today would be the right thing to do anyway. Right? The Conservation Reserve Program dates back to the early mid-1980s. It was a good idea then, even without concern about climate change, and it's a good idea now. In fact, if the Conservation Reserve Program or other similar programs were prepared and presented today, they might very well be cast in the light of how we cope with the new carbon economy, how we cope with climate change, how we cope with water quality issues in new ways that weren't on the radar back in the early 1980s. And so what we do on the landscape matters. It matters greatly, and it's the right thing to do. We should do it no matter what the circumstance is. I feel this is the right time for this conversation. There's been, if you will, a mainstreaming of this conversation. A few weeks ago, many of us were here in Des Moines at the World Foods Prize meetings. There was a whole panel on climate change and climate smart agriculture. The executive at Corteva talked about it. People from USDA talked about it. People from industry and private farmers have talked about it. This is here and this is now. Just this past week, on the 21st, Deputy Secretary of USDA Steve Sensky reported that it's critical for U.S. agriculture to think about climate change, and that we should implement climate-smart agricultural practices. That's coming directly from USDA, and I know it's coming from all of you as well. I remind you that change is not new to the agricultural sector. 100 years ago, there were no soybeans grown in Iowa. And look what we have now with soybeans. The people who thought about the Dust Bowl and the soil erosion during that time were talking about it and thinking about it before the crisis happened, and yet we waited for the crisis to happen for our nation to act with respect to soil erosion. We still have soil erosion concerns and problems. They are still significant. It takes a long time to grow soil and a short time for it to wash away. In 1972, when President Nixon signed the Clean Water Act and the Clean Air Act, some say he did so reluctantly, but nevertheless he did, was a time when our nation had not adequately responded to the needs for clean water and clean air. And so there was a regulatory approach taken to ensure that we would have better air and better water, and there is nobody who could suggest that the air and the water are not better today than they were in 1972 when the act was signed into law. We owe it to ourselves to dig deep and dig hard to do the things that are necessary so that we can push us forward to a more sustainable, more profitable, more productive future on our landscapes without being forced to do so by acts of law. Let's do that. Let's figure it out. And finally, farmers are among the most conservative folks there are, and they're the greatest risk takers as well. What kind of strategy is it to put seeds in the ground and hope it'll rain, or hope it won't rain, or hope it won't get too dry? That's a difficult strategy for anybody to follow, but farmers do it every year. And so I challenge us all to work hard to help the people who manage our landscapes to be able to do the right things. Much of the science and technology to get started is already with us. There's much more to develop and to understand. Our panelists today are going to address those topics, and then we'll take your questions, and looking forward to this conversation. So with that, we'll start with Dr. Rosenzweig, who will make a presentation, and then one by one, you folks will come up and get our conversation started. Thank you so much.
Thank you, Dean Robinson, and thank you to Ernie Shea. He and I work on the Global Alliance for Climate Smart Agriculture together, and thank you to Solutions for the Land. I always love to come to Iowa because I am also an agronomist by training, and it's really great to come to the heartland where you all really are the leaders of the field. But my work is focused now on the global scale and how climate change will affect not only agriculture, but the food system globally. So what I'm going to do in my presentation is share the highlights from a recent a report from the Intergovernmental Panel on Climate Change. That's the IPCC, that's the acronym. And in August, a special report from the IPCC was agreed by the governments of the world and the special report was on climate change and land. And I worked on the food security chapter with a group of authors from from agricultural regions and different aspects of the food system throughout the world. So the first major finding from the special report on climate change and land, the acronym for that is CIRCLE. And here's the circle of the food system. And probably for climate change and the work that's been done on climate change, probably over 95%, just a huge majority of the work has been focused on the production side of how climate change will affect production. But the perspective now and the focus now and the approach is now changing to be thinking much more broadly to the food system. How will climate change affect the inputs? How will it affect, of course, the production, still vitally important? How will it affect the supply chains? And finally, how will it affect the demand and the consumption side? And it's only when we take all of those aspects of the food system and think about that in relation to a changing climate, in regard to both reducing greenhouse gases and adapting to the climate changes that we've just been hearing about it, then we can actually develop integrated outcomes and policies to address it. And what are those outcomes for the whole food system? And they are, of course, health and well-being, food security, as well as the climate solutions. So why did the IPCC take this food system approach? Why is it going beyond agricultural production in thinking about climate change? And it's because agriculture and food is at the heart of so much of climate change. So on the left-hand side, you see that when you count up all the greenhouse gas emissions from the whole food system, not only just the production side, it is producing a very large proportion of total greenhouse gas emissions. And this is new work that came out in this report, 21 to 37%. This is huge, potentially a third of all emissions. So agriculture and food, the whole food system, is playing such a key role in the challenges and the causation side of climate change. And all of this is projected to increase, of course, driven by population increase and by income growth. Now, but we all know on the other side that climate change creates additional stresses, and it already is. It's not just in the future. It already is creating additional stresses through, for example, extreme events on food systems. And so as the climate warms globally, the risk of food system instability in the whole system, is rising and becomes very high. So you see that because of these two parts, both the greenhouse gas emissions and the resilience side, the adaptation side, you see the importance of developing integrated policies that operate across the whole food system. One of the things that the IPCC does is it's not just all in the future. Climate change is no longer. In the beginning, when Jerry Hatfield and I started studying this together at the American Society of Agronomy, it was all projections into the future. What this is showing is that these are observed changes now in all parts of what are known as the four pillars of food security. The first is availability. This is the production side. So we know that climate change has had a negative impact on wheat and barley yields, for example, particularly in southern Europe, which has had very strong heat waves and water stress. There's also been clear effects of climate change on food price spikes. For example, the heat wave in Eastern Europe in 2010 and 2011. Now, it's not every single thing in that food price spike was caused by climate change. It's not like that. Multiple factors go into any one of these very complex events. But it is possible to tease out, and the IPCC scientists do tease out, that there is a role of the changing climate. What about in utilization? This is in, for example, the nutrient and the quality of food. Here on the bottom left, we have that reduced quality of apples. This is in Japan, where it's getting warmer without the vernalization on the apple crop is affecting the quality of the apples there. For example, this is a documented effect. And finally, stability, because food security is about provision of food and access to food and availability of food and utilization of food all through the year, all through the seasons, and all through year by year. And so we see, for example, the massive flooding in Pakistan in 2010 that led to huge loss of their food reserves. Now, the IPCC, that was the observed things that are happening now, but the IPCC makes the projections. So these are projections of AgMIP, that it's a network of agricultural and food modelers from around the world that Jerry and I are founding members of. And AgMIP makes the projections of record. And this is showing for the 2080s what would happen with the higher temperatures. And this is basically for the greenhouse gas trajectory that we are on now. And we see the potential for negative effects globally, especially in the lower latitudes where the developing countries are. In the mid and high latitudes, more where we are located here in Iowa, there may be small benefits at moderate to medium temperature increase, but eventually, with higher temperatures, this map gets to be negative everywhere. There's also new work showing that high CO2 can affect the nutrient quality of grains, both in terms of the protein content and micronutrients. This is very new work that's coming out from looking at the detailed free air release experiments in the grains that were actually grown with high CO2. So there's the potential, again, this is new work coming out, that there may even be nutrient issues with the high CO2. let's turn to the solution side and what the report said about solutions. So first, on the supply side of the food system, there are so many that you all here in Iowa have been taking the lead on, that have tremendous potential for reduction of greenhouse gases. This has to do with carbon sequestration, but on the livestock side, improve feed digestibility, use of feed additives, changes in land use, animal management, rangeland rehabilitation. All these are on the supply side that can do a great deal to contribute to reduction in greenhouse gas emissions from the food system. The report also, for the first time, brought forward the potential for demand-side mitigation. And this has to do with the consumption and dietary choices, potential for dietary change. This is really challenging because we know that, for example, livestock production is very high in greenhouse gases. And if the whole world, by the way, these are projections of if the whole world became vegan, which of course is highly unrealistic. But the potential for dietary change and choice is something that we need as a community of the food system to begin to think about and grapple with potential changes, even from the consumption side in the food system. Also, what came out in the report that was actually one of the big results was a focus on food loss and waste, because again, this is something across all those parts of the food system that we can all do better on, and because an estimated, again, we're 25 to 30%. It's astonishing of all food produced is lost or wasted. This contributes about 8 to 10% of all anthropogenic gases. It's very large. So this can be reducing food loss and waste in the parts of the food system that we work on can play an important role as well. Again, though, none of these statements can be just blanket, cookie cutter, different contexts in different countries and in different locations, different production systems, different farming systems have to be taken into account. So the IPCC is not making major statements that everybody has to do one thing or another. It's bringing forward the science behind these potential solutions. Here's the possible trade-off, and something you all are very well aware of. I think I have just one or two more slides. And this has to do with the potential trade-off between food security and bioenergy and carbon capture and storage. So what the report found was that some of the potential for bioenergy can increase demand for land conversion and can cause competition for food production. This can lead to adverse side effects for adaptation, desertification, land degradation, and food security. But the report also found that it can be done, and this is something I think that's being very much tested and explored here in Iowa, that bioenergy can be done sustainably. We have to work hard to make it happen. And we also have to be careful about how much land we're doing it on, so that we can have integrated into sustainably managed landscapes, that there can be a real handshake between the climate change reduction in greenhouse gases from bioenergy and also the food production that we still have to, of course, make sure that we feed everybody. Coming just now to the final thought about this, something that I was mentioning before about the regional aspects. So this is a very complicated slide, which is looking at, for each region of the world, each country, the area, agricultural area, the production, the potential for trade, and the potential drivers for changes. And what do you see here? Every region is different. So not only I know what happens here is very important, but we also have to be very cognizant about what's happening in the other agricultural regions of the world, so that we are all developing a system that is right for the regional context, like right here in Iowa, but then as well fits in to the larger global solutions. This is the last slide to say about a final, I would say, major point that the report made, which is that the stability of food supply with climate change is expected to decrease, or to put it in the opposite, that the risks, climate risks in food supply and in the food system are increasing. And this is something that we all have to be, as we are creating the solutions, both for the mitigation side and on the resilience side, we have to be aware of this. And my task was to do the global perspective, but I just put one slide to lead into the other colleagues on the panel who are going to be sharing what's going on right here in Iowa, just with the example of the very, very wet year that you've had in the past, right now in this period. Thank you very much.